Hello students, in this video we are going to cover some topics which have been not covered yet here in light. As we can see here, law of reflection of light here. Let me put it on center here. As you can see here, this is a plane. This is incident ray which is coming. This is reflected ray. This is normal. This is incident angle. This is reflected angle. This is plane mirror. The angle of incident is equal to the angle of reflection. The incident ray, the normal to the mirror at the point of incident, and the reflected ray all lie in the same plane. Earlier we have talked about mirrors. So what is mirror? Mirror is a glass sheet which is polished behind the which is polished from one side and other side is bright and polished, as we can see here. In this mirror you can see there is a mirror. This is a mirror, plane mirror. In this mirror, incident ray or incident angle is equal to the reflected angle always. Here, image formation by a plane mirror. As we can see here, this is a plane. This is our object. This is our object. This is eye. This is image. This is object. Light is coming, is striking here and going back to eyes. But the virtual part of this portion or this object here, the eye is seeing that the object is placed here, not here. Here there is a image of the object here. This is the image, this is the object, this is our eye. Same here, letter P is here. Sorry, letter P is here. The image is formed there. How is formed? It can be explained as this. Suppose this is a line, this is P, we have, this is mirror, okay, plane mirror. So what happened? Light comes here like this. It goes and strike back. is goes and strike back. Same for here, is come and strike back. Same for here, is comes and strike back. But here, virtual part. As we can see here, this is P. The light rays come, strike and back. Okay, these three lines, and these three lines here, the rays is coming from the all the angles. The rays is coming from the all the angles, so the reflection of P is can visible from the all the angle of the plane mirror. So this will be formed like this. This is coming here, and this is goes strike back here, like this. This one like this, and this one like this. We make the virtual part of it. This here, this here, this here. And this will be formed like this. And we are talking about mirror. There are three type of mirror: plane mirror, concave mirror, convex mirror. What is mirror? Mirror is a sheet of glass which is polished from one side, so the other side is shiny and bright. Same here in this figure. In this one, is a poster here. This is a plane mirror, and this is a image formed here, and we can see the image from here. Same here, this is a wall mirror, a plane mirror. This is the hand, and this is the image. These are the real one. This is the image. This is mirror. This is image. This is real object. This here we talked about plane mirror. Now concave mirror and convex mirror. So you can see here you can see this is a hollow ball. This is a hollow ball. We cut this portion. We cut this portion. This one. This portion. We cut this portion of this hollow ball and polish outer side of its side. Here as you can see in these mirror the outer convex surface is polished so that inner concave surface become bright and shiny, so reflection occur from the concave surface. These mirror are conveying mirrors as they use to coverage the light's ray. These mirrors usually form a real image of object, except when the object placed very close to the mirror. If the object is very close to the concave mirror, so image will form virtually inside the mirror. We will talk about we had talked about how the images formed virtual and real concave mirrors. In these mirror, inner concave surface is polished, so inner surface. In concave mirrors, the outer surface is polished and inner surface is reflecting surface, bright and shiny. In concave, the inner surface is polished and outer surface is polished and outer surface is bright and shiny. Difference between them: these are spherical mirrors, those are outer bubbled surface is polished so that the inner surface is the reflecting surface. Those are spherical mirror, those inner surface is polished so that the outer bubbled surface is the reflecting size. It is covering mirror, it is diverging mirror. It has a real focus, it has a virtual focus. It is used as reflector in a torch and searchlight. It is used in a vehicle as a rear view mirror. And in this figure, in this figure, as you can see, we cut this part and this is the our mirror. That can be concave or convex. So we talk about here the center point of this mirror. This is the center point. This is pole. If we talk about whole hollow ball, the center of this hollow ball is called center of curvature, and the what and the center what is focus? The center of pole and the center of curvature is called focus. Here you can see here you can see the center of the reflecting surface of the spherical mirror is point called the pole. It lies on the surface of the mirror. The pole is usually represented by letter P. Here, as we talked about, the center of this portion we have cut from the hollow ball. This center, this is called pole. Center of curvature, the center of whole hollow ball. The reflecting surface of a spherical mirror from a part of sphere. The sphere has a center. The point is called the center of curvature of the sphere mirror. It is represented by letter C. The center of curvature of a concave mirror lies in front of it. However, it lies behind the mirror. In case of concave mirror, the distance between P and C is called radius of curvature. The distance between P and C, this is P, and C center of curvature, and which distance between them is called radius of curvature. This radius of curvature. You have to write down this principal axis. Principal axis. What is principal axis? Here we can talk about principal axis. This is our mirror. This is pole. This is center of curvature. A line going to the point center of curvature and pole. This line is called principal axis. A straight line passing through the pole and the center of curvature of a spherical mirror, the line is called the principal axis. The principal axis is normal to the mirror at its pole. Principal focus. In case of concave mirror, what is focus? Here in this figure we talked about pole. This is pole, this is center of curvature, and the middle point of both is focus, which is denoted by F. In case of concave mirror means outer surface is polished, so light come and strike and goes through focus. All the lines come, strike and goes to the focus. In case of this is concave. In case of convex mirror, this is principal axis. This side is polished. Light come here. The light comes. This light is coming, and this is striking back. This is coming. This is striking back. Same here. This is coming. This is striking back. So here, if we make the virtual part of it, here, these all the line is coming from the focus. Here, this line going from the focus, and this line are coming from the focus. When a number of rays parallel to the principal axis fall on a concave mirror after reflection, they have meet or intersect at a point on the principal axis of the mirror. This point is called the principal focus of the concave mirror. It is represented F. It is exactly at the midpoint between P and C. On the principal axis, focus of the concave mirror is real. In case of concave mirror, convex mirror, rays coming parallel to the principal axis after reflection diverge in the different direction. If they are projected behind the mirror, they meet at the virtual point behind the mirror. This point is called focus of the convex mirror. So focus of the convex mirror is virtual. Apparatus. The diameter of the reflecting surface of a spherical mirror is called the apparatus. Diameter of the hollow ball is called the apparatus. Focus length. The length between the pole and the principal focus of the spherical mirror is called the focal length and is represented by F. Since F is located at the midpoint of the distance between P and C, is that we can say focus length is the half of the radius. R is equal to 2F. Here you can see in this figure, this is center, this is pole, in the middle of here this is focus. So focus is the half of the radius. So we can say R is equal to 2F. Now you have to write down this all. What is pole? What is center of curvature? What is principal axis? Principal focus in case of concave mirror, in case of convex mirror, apparatus, and focus lens, and draw this figure and upper one. When the object is present at infinity, the rays that come from infinity are supposed to come parallel to the principal axis so that the ray after reflection meet at focus, so a very small real image is formed. Here we can see in this figure the these lines are coming, these lines are coming and strike here and here, then reflected back. This is the focus, this is the pole, this is the center. The image is formed at focused, very small, inverted and real. Second condition, when the object is placed between infinity and center of curvature, means the object is. Now we talk about real image and virtual image. What is real image and what is virtual image? Suppose there is a mirror and we saw inside the mirror, so we saw image. So the object is real and image is being formed behind the mirror. So image is virtual. Real image, an image which is actually formed by the light ray that coverage across each other, is called a real image. The image can be taken on a paper or a screen. The image is always formed in front of the mirror toward the shiny side surface side. The type of image is always inverted. Real image is always inverted. The image which is appeared to be formed behind the mirror is called a virtual mirror. Which is formed behind the mirror, that is virtual mirror. Which is formed which is actually formed by the light, which is formed by the light, these are the real image. And which are formed behind the mirror, these are the virtual mirror images. This is not a real image because it is not formed by the actual light ray. When actual light ray diverge from each other, we can project their path behind the mirror. These virtually projected ray from this type of image, this image cannot be taken on screen or paper. It is formed always behind the mirror, is that against the shiny surface, this side of mirror is always upright. Here, last time we had talked about image formation by concave mirror and convex mirror. We will take a fast view on image formation by concave mirror. When object is present at infinity, means object is placed here between the infinity and the curvature. This is the curvature, see, this is the focus, this is the pole. Okay, let me zoom out. This is the pole, this is the focus, this is the center of curvature, this is the object, this is the image. This line is coming here, strike back, goes from the pole. This is also going from pole, sorry, focus. This is going from focus, strike here and goes parallel to the main axis. This is going from the curvature, and after all we find here is an image. This is the image which is formed here. When the object is present at the center of curvature, when the object is placed at center of the curvature, this is C, this is F, this is P. Image is real, inverted, similar to the object size, and at the center of curvature. This is formed like this. We also studied these all 6 figures before. This is our curvature, this is focus, this is pole, and object is placed between center of curvature and focus, and this is made like this. Try to draw these all graph by yourself. This object is placed at focus, and this one object is placed pole and focus. So image is here, the image is formed, all the image are formed here, this side, but now this image is formed the right side. All the image is formed left side, but this one is formed right side. This is virtual image. This is formed behind the mirror. Same here, image formation by convex mirror. There are just 2 conditions: when the object is placed at infinity or between pole and infinity. There are just 2 conditions. When the object is placed at infinity, the image will form at the pole, sorry, focus. When the between the pole and infinity, the image will form focus and pole. Use of concave mirrors, we already talked about it. Use of convex mirror, we already talked about that. These are used on malls, cars, for human safety. This is the mirror formula.